For this worksheet on series circuits, we're asked to create a VIRP chart for each problem such that we can solve for all of the unknown or missing variables that we have. So for number one, we look and we have two resistors. So we go through and that means that we need two resistors in our chart. We also know that we need a row to calculate your total resistance or your total equivalent resistance. We also know that we are solving for VIRP, as we always do when solving with these charts here. So this is what your chart should look like. The first thing that we can do is we can go through and we can label our total voltage, which they tell us is 24 volts. We know that we have two resistors. We can call it however we want. We can call this one R1, you can call this one R2, or you could switch them. The choice is totally yours. I'm going to go ahead and I'm going to say that the 3 ohms is my R1, the 5 ohms is my R2. Okay, so now solving for R total, or REQ. REQ is equal to R1 plus R2. I only have two terms because I have two resistors. So that means that we have 3 ohms plus 5 ohms, which is going to be a total of 8 ohms. The next thing that I can do is use V equals IR, and I can go ahead and I can solve for my unknown current. So 24 volts is equal to I multiplied by 8 ohms, which will give us I equaling 3 amperes. Because this is a series circuit, I know that all of my current is going to be constant. So I have 3 amperes for all of my currents here. Solving using V equals IR for my R1, I'm able to go ahead and I can say V equals IR, which is equal to 3 amperes multiplied by 3 ohms to give us 9 volts. And if I do the same for this one, you should have ended up with 15 volts as your answer. Solving this column here for power, I'm going to use the formula P equals IV. And if you do that, the first one, you should get 27 watts. There we go. The second column, or the second row, you should end up with 45 watts. And the last row, we should end up with 24 multiplied by 3 to give us 72 watts. Okay, moving on to number 2. Let's erase all of this. Okay. For number 2, if we look at this one, we have a total of 3 resistors. So now our chart needs to make sure that we have 3 resistors. So R1, R2, R3. We also need a row for our total. So just make sure you go through and fill in your different columns in your chart each time. Okay. So we were able to go through, we're able to fill in a couple of different things. The first 72 volts is our total. So 72 volts. They tell us that our R1 is 8 ohms. Our R2 is 6 ohms right here. Here was R1. And R3, they tell us, is 4 ohms. Again, plugging in using your circuit rules to solve for this right here, we have REQ equals R1 plus R2 plus R3 to give us a total of 18 ohms. Solving for this here first, we have V equals IR. Solving for your R, 72 divided by 18, you should have ended up with 4. Whoops. Oh, there we go. Okay. 4 amperes. Because this is a series circuit, I know that I have a constant current all throughout. You can go ahead and you can use V equals IR to solve for the remaining voltages. So I times R for all of them. The first one, you should end up with 32 volts. The second, 24 volts. And this third one should be 16 volts. Solving for power, power equals IV. So 32 multiplied by 4, you end up with 128 watts. 24 times 4, you end up with 96 watts for the second. The third, 16 times 4, gives you 64 watts. And the last, 72 times 4, gives us 288 watts. Okay. For number 3, let's get rid of all of this. All right. For number 3, this one, we have 2 resistors. So we know that we need R1 and R2. We also know that we need a third row for REQ. We're going to go through, we can fill in everything that we are missing. So V, I, R, and P. All right. So as we go through here, we know that our total voltage is 12 volts. We also know that the current in my circuit is 2 amps. That's a positive 2 amps there. Okay. Well, we're just going to draw this line. All right. So positive 2 amps. Because this is a series circuit, I know that my current is constant always. And that's all they tell us. They do tell us, though, however, that V1 is equal to V2. So that means that V1 plus V2 must be equal to 12 volts, our total, where V1 and V2 are the same. So really, you end up having 2 V's, when put together, equal 12. V should be equal to 6 volts each. Once we have that, we can then go ahead and we can use V equals IR to be able to solve for all of our unknown R's. So for this one, for instance, you end up with 12 volts equals 2 amperes multiplied by R. R should be equal to 6 ohms. You do the same for the others. For this one, V equals IR. You end up with 6 volts equals 2 amperes multiplied by R. R should be 3 ohms. And because both of these voltages are the same, both resistors should also be the same. If you solve for P and you solve for P correctly, you should have ended up with 12 watts for R1, 12 watts for R2, and 24 watts for your total power. Okay. Solving for number 4, you have 3 unknown resistors here, which means that we need R1, R2, R3, and REQ. Plugging in our our VIRP, we can go through and we can plug in what we have. So they tell us that V1 is 9 volts, which means that V1 is V going through, what did I do? Bear with me. Oh, here we go. Okay. V1 going through R1 is 9 volts. So this is 9 volts. V2 is 12 volts. V3 is 6 volts. And I in the circuit is 3 amperes. Well, we know that this is a series circuit, so all of our currents are the same. I also know that I'm able to solve for my total voltage, I can use my total voltage being equal to V1 plus V2 plus V3. So 9 plus 12 plus 6 is going to give us a total voltage of 9 plus 12 plus 6, 27 volts. I then can go ahead and I can use V equals IR to solve for my resistances. So V equals IR for the last one, you have 27 equals 3 times R. R should be equal to 9 ohms. You can do the same for all of the other ones. This first one should be 3 ohms. This should be 4 ohms. And this last one should be 2 ohms. Solving for power, P equals IV. This first, we should get 27 watts. We should get 36 watts for R2, 18 watts for R3, and then 27 times 3 should give us 81 watts total. For our last question, number 5, we have to erase some of this stuff, so give me 1 second here. All right, for number 5, we end up having 1, 2, 3, 4 resistors, which means that we have R1, R2, R3, R4, and we still need our total REQ. Okay. We go through and we fill out our chart as per normal. So V, I, R, P. You can go through and add in a couple of things. We know our total voltage is 12 volts. We know that R1 is going to be 3 ohms. We know R2 is going to be 7 ohms. We know R3 is going to be 6 ohms. And R4 is going to be 8 ohms. Okay. So if we go ahead and we solve for our total resistance, R total equals R1 plus R2 plus R3 plus R4. We end up with 3 plus 7 plus 6 plus 8 equals 3 plus 7 plus 6 plus 8 gives us total of 24 ohms. So our total is 24 ohms. If we want to solve for I, we can use V equals IR, where V is 12 volts, I is what we're looking for, and 24 ohms is our total. If we solve this, we find that I is equal to 0.5 amperes. 12 divided by 24. So if I know that this is 0.5 amperes, I know that each one of my currents in my circuit should be labeled as 0.5 amperes because, again, this is a series circuit. We can then go ahead and solve per normal. The only thing different with this one is that we had one more row. But all of the math, all of the way of thinking about the problem should be the same. So if we're solving for this right here, solving for R1 in terms of its voltage, we end up with V equals IR, as we normally do. V is what we are solving for. I is 0.5 multiplied by 3. 0.5 multiplied by 3 gives us 1.5 volts. If we do that all the way down our table, the second, we end up with 3.5 volts. The third, we end up with 3 volts. And the last, R4, we end up with 4 volts. If you added all of these together, you should end up with 12 as your answer. To solve for power, we can do the first one here together. P equals IV. I is 0.5 amps multiplied by 1.5 volts. 0.5 multiplied by 1.5 gives us 0.75 watts. If we do that all the way down our table here, we end up with the second being 1.75 watts, 1.5 watts, 2 watts, and our last to be 6 watts.